Hello there. My name is Thomas and I'm from Investment Excel. Many people on Investment Excel, they have asked me how a casino works. What is the statistical model underlying the basic business game, defined as just the game at the table. And as I will show, the profit in dollars or in percentage from a casino game is positive in the long run, where in the long run is defined as with the number of spins going to infinity, then the profit is getting more and more locked in. So eventually, after many years in business, many spins, repeated games, a sure profit is locked in. Please note that we will not look at a general casino business model where other cost factors are included, like staff, buildings, advertising, and so on. And this is always very important to remember when you talk about these playing houses, these casinos, that they have other costs than those implicit in the game itself, the probability of paying out in the game. So this is why you cannot just create a casino and make a lot of money. There are many other costs to consider. We will show how the casino game works with a simulation given a binomial distribution and also a normal distribution. This video and the Excel worksheet are available for download on investmentexcel.com and spotify.com. Let's go into the casino. And more exactly, we will go to the roulette table, where we have 18 black numbers, 18 red numbers, and in this case 1 green number. In some cases, particularly in the US, you'll find 2 green numbers, leaving the total numbers of 38. But here we have 37 numbers, each with a chance of being rolled of 2.70, that the ball in the roulette gets on that particular number, 2.70. We also see the chance of getting a black, slightly lower than 50%, because we have 37 outcomes, and also on red. The payout factor to the player, if a particular number is hit, a straight up hit, is 36, and it's double up if there is a successful color play on red or black. Let's look at this basic setup at the casino table from a statistical point of view, and in particular we will look at the random payoff when you play straight up. So this is straight up game. I just call it SU straight up. So a player plays on exactly one number. Seen from the casino side, we have a fail if there is a straight up hit. That's one outcome. And the other outcome if there is not a straight up hit. This is a success seen from the casino, obviously. Seen from the player, it's just reverse. If there is a hit on the straight up number, the casino pays 36 on every dollar. And if there is not a hit, they take the money and no cash flow to the player. So this is the cash flow. If you look at it from a profit side, which is ultimately the interest of every investor, including the casino. In the case of the straight up, they pay out 36, but they get $1, which is the initial investment from the player. So he puts down $1 on a particular number, and if it's a success for the player, a fail for the casino, then the casino has to pay out 35 additional dollars. So the total profit, of course, is minimized by $1. And here, in case there is a success for the casino, they will just take the $1 at the table. And again, we are operating under the same probabilities, the two outcomes, straight up 2.70, not straight up the rest. Okay, so this is the basic cash flow and profit binomial model. Now I'll just show you how it works. If we play number 26, so player bets $1, payoff if outcome is 26, and this is the cash flow, minus 36, and 0 if not. Expected payoff must be minus 97, so the probability of ending up in this scenario times the cash flow plus probability of this times the cash flow, so essentially leaving a expected payoff equal to the probability of a fail times 36. The expected profit in dollars is simply $1 minus the expected payoff, and here we have the absolute golden number for the casino, 2.778, which is the expected profit in percentage. And remember, this is the profit in dollars, but we need to recalculate it to get it in percentage. And the way to do it is simply to remember that the casino gets $1 as income or as profit, and then they have to divide it by their investment, and their investment is the expected payoff. So it's like a return for seen from the casino. They get in $1 and they pay out 0.9730. So take those numbers, the relative value, and you get this. This is the absolute crucial number for the casino. So the expected profit on every, not just this game, but every spin is 2.778. Let's see if I spin 5,000 times, what happens. So here I spin, first spin, income 1, no payout. So obviously we didn't hit 26, and this is the way I do it. So the individual profit is just the income minus the payout. So first down here at number 86, you see that there is a straight up. And if we do that and we calculate the average rolling over 5,000 spins, you will see a feature here, which is what we call the law of large numbers. That is, the average of the profit of the every spin profit is getting closer and closer to a fixed number, which is the population value, which is equivalent to this number. So remember, the casino is a population game. It's not a sample game. It's really the statistics underlying it are based on objective probabilities. So here you have the law of large numbers governing the long run or many spin dynamics, and you will see after some initial volatility it settles towards the population value of 2.778, and I have put it in here. The expected profit is 2.778 on one spin, and the standard deviation is this. And this is the simple binomial formulas for profit, or for the mean, and for the standard deviation. All right. So this is the law of large numbers. A much more important number is, much more important measure is the central limit theorem, that states that this movement is governed by a functional relationship which is in the central limit theorem. And it says that the distribution of the average profits is normal, with a standard deviation dependent on the size or the number of spins. And this particular mathematical relationship can be used actually to calculate the lock-in status of the profit. So at which point, at which number of spins can the casino expect to have, say, a 99% chance of achieving the average profit of 2.778. And I have shown it here by just spinning several times, first 250, then 1,000, 2,000 and 5,000 times. And what we will see is a remarkable tendency. Here we have on the x-axis the profit in percentage, and you see that the distribution around the profit gets more and more narrow, and finally it collapses almost into one single point, being the expected profit of 2.77%. So the more spins, the more locked in is the more sure thing is the profit of 2.778. This is the whole idea of the casino operating in the long run, that they have the statistical functionality or relationships with them. And I just tried here to show it. The confidence interval, or the locked-in interval, if you like, of the expected profit as we go higher and higher in number of spins at the table. And first, you should know, and I forgot to say that the normal distribution here is a result also from the central limit theorem that states that if you have more than 30 trials or 30 spins, the distribution will be approximate normal. So you cannot really trust in the first numbers here, or at least this one, from a normal distribution perspective. But if you go down, this is indeed the classical confidence interval in a normal distribution, and it says here, if the players play 1,000 times, there is a 99% chance that the profit will be in this interval. So minimum this and maximum this. If he spins further, you see how the interval collapses towards the mean. And here, after 10 billion of spins, we see we have almost locked in with a 99% chance the 2.78. And this is the reason why people say that the casino in the long run is a sure thing. If we transpose or transform this into money, and we still assume that there has been a play of $1 for each 10 billion spins, we can say now that there is a 95% chance that the profit will be higher. Sorry, there's an H missing here. Higher than this number times number of spins times the investment per spin, $1. So 277 million US dollars can be expected with a 99.5% chance. Again, after 10 million spins. Alright, so here are the numbers, the fundamental business model of the casino just at the table. But again, remember, casino is many other things, with staff and all this, toilets and so on. But of course, many people they start games like this on the internet or as app, just to avoid these other variable costs that are not related to the table itself, in order to profit from this statistical feature. Alright, thank you.